Hi folks, I hope you've seen the final review sheet that I posted on Canvas. It's got a bunch of review problems that if we were still meeting in person, we'd spend the last day or two of class going over those in class. Since we can't do that, I do have the complete solutions posted, but I'm also making this video to try and talk over some of these so that you'll know for sure how to do them. So I won't go over all of them in great detail, but if you still have questions about any of these, if you're still not sure how to do any of these, ask me, send me a message, and I'll try to get back to you and explain it better or make another video where I go into more detail or whatever would help. So in problem number 2, there are these 10 data values. Constructing a frequency distribution means listing what those are and how many of each there are. So here there are 5 freshmen, so the frequency for the freshmen is 5. Sophomores 2, juniors 1, seniors 2, and that's a total of 10 because there are 10 in all. The relative frequencies come from taking each frequency divided by the total, how many there are in all. So like 5 divided by 10 would be 0.5, but then to convert that to a percentage, you would move the decimal point 2 places to the right so that it's 50%. And the percents do add up to 100%. A pie graph for that set of data would look like this. Since the freshmen make up 50% of the data values, half of the circle should be the section for the freshmen. Then the other half is devoted to 20% seniors, 10% juniors, and 20% sophomores. So I made the two 20% sections the same size as each other, and then each one of those is twice as big as the 10% section. A Pareto chart would look like this, and it does have to be arranged in order of frequency. So the freshmen are first because there are more of those than anything else, and the juniors are last. And notice that my scale starts with 0 at the very bottom and goes up consistently so that there's the same amount of space from 0 to 1, 1 to 2, 2 to 3, and so on. So the sophomores and the seniors, there are 2 of each of those, so they look the same height as each other, and they look twice as tall as the juniors bar, and less than half as tall as the freshman bar, because 2 is less than half as big as 5. In number 3, we are working with this set of 7 numbers, 7 scores of people who took a test. To find the mean, you would add up those 7 numbers and then divide by 7. And that comes out to be 60.4. To find the median, you would arrange those in order, like from lowest to highest, they go 42, 55, 59, 63, 67, 67, 70. And the one that's in the middle is 63. Notice that 3 of these numbers are less than 63, and the other 3 are greater than 63. The mode is the most common value. There are 2 67s and only 1 of anything else. So 67 is the mode. The range is the highest minus the lowest value. So here that's 70 minus 42, which is 28. Then to calculate the variance and the standard deviation, first, I've just listed all 7 of those numbers. And then I've taken each one of those numbers minus the mean. Remember, the mean was 60.4. So 59 minus 60.4 is negative 1.4. 55 minus 60.4 is negative 5.4, and so on. And then I took each of those numbers and squared it. So negative 1.4 squared is positive 1.96. Negative 5.4 squared is positive 29.16, and so on. Then I took all of those numbers and added them together. So they add up to 555.72. Now it did say this is a sample, so we divide this total by n minus 1. Here the n stands for how many numbers there were, which was 7. So I'm dividing by 6. So 555.72 divided by 6 is 92.62. So that number is the variance. And then to get the standard deviation, I take the square root of that number. And that comes out to be about 9.6. So that is the standard deviation. Number 4 says compute the coefficients of variation and tell which is more variable, height or age. The coefficient of variation is what you get when you take the standard deviation divided by the mean and then multiply by 100. So for height, that would be 5 divided by 38 times 100, which is 13.2. And for age, that would be 17 divided by 245 times 100, which would be 6.9. So because the coefficient of variation is higher for height than for age, we would say height is more variable than age is. Number 5, I gave you the class limits and the frequencies and asked you to fill in the boundaries, the cumulative frequencies, and the midpoints. Notice the boundaries go from 0.5 below the lower limit to 0.5 above the upper limit. So when the limits are 3 to 7, the boundaries are 2.5 to 7.5. The next class goes from 8 to 12, so the boundaries there are 7.5 to 12.5. And notice that the upper boundary of one class is the same number as the lower boundary of the next class, and that the limits and the boundaries all go up by the same number each time, which for this frequency distribution would be 5. That's the width of each class. To find the cumulative frequencies, you add up the frequencies. You start with just 1, but then 1 plus 9 is 10, plus 8 is 18, plus 5 is 23, plus 1 is 24. And for the midpoints, halfway between 3 and 7 would be 5. If you can't just see that, you can add those together and divide by 2. 3 plus 7 is 10, divided by 2 is 5. 8 plus 12 divided by 2 would be 20, divided by 2 is 10. So the midpoint of the second class is 10, and so on. To find the mean of grouped data, when you're working from a frequency distribution, the formula looks like this, and it means to take the sum of midpoint times frequency divided by the total frequency, the number of individual data values that are grouped into those classes. So to do that here, I had to take each class and multiply the midpoint times the frequency. So 5 times 1 is 5, 10 times 9 is 90, 15 times 8 is 120, 20 times 5 is 100, 25 times 1 is 25. I had to add those up. So that's the number on top, that's 340. And then I divide by n, which is the total frequency, and that is 24. So 340 divided by 24 comes out to be 14.2. Notice that that is somewhere in the middle of these lengths. The modal class is the class with the highest frequency. So here, the highest frequency is 9, and that goes with the 8 to 12 class. So there were more eels that were somewhere from 8 to 12 inches long than there were in any of these other classes. A histogram for this set of data would look like this. Notice it is labeled with the class boundaries. So the first class is between 2.5 and 7.5. The second class is between 7.5 and 12.5, and so on. So the boundaries are the points between one class or one bar and the next. And then the heights correspond to the frequencies. So for the first class, it only goes up to 1. For the second class, it goes up to 9, then 8, 5, and 1. Notice we start with 0 at the bottom and go up with a consistent scale. Same amount of space from 0 to 2, as from 2 to 4, as from 4 to 6, and so on. A frequency polygon for the data would look like this. And there we go. It's labeled with the midpoints of the classes, 5, 10, 15, 20, and 25. So above each one of those midpoints, we have a dot going up to the height of the frequency for that class. We also have dots down at 0 level outside of that range. So we have these 5 dots, one for each class, and then we connect things down to 0 level, down to the horizontal axis at the end. And an ogive for the data, that's based on the cumulative frequencies. So we have the class boundaries on the horizontal axis at the bottom. We start at 0 for the first boundary, and then from there we go up to each cumulative frequency, up to 1, and then 10, and then 18, 23, and 24. Number 6 says, on a test, if the mean score was 69 and the standard deviation was 0, what was the high score? Remember what standard deviation tells you. It's a measure of how spread out the numbers are, how much variation there is, or deviation. If there isn't any variation at all, that means that all the numbers are exactly the same as each other. And if they're all exactly the same, and the mean is 69, that means all the numbers must have been 69. So the high score was 69, the low score was 69, all the scores were 69. To answer number 7, you just have to remember the rule about the probability that something will not happen is 1 minus the probability that it will happen. So 1 minus 0.15 is 0.85, or 100% minus 15% is 85%. A jar contains 5 pink, 3 green, 1 red, and 4 purple jelly beans. If you add that up, that means that there are 13 in all. The probability that a jelly bean selected at random is pink or purple would be 9 out of those 13. There are 5 pink plus 4 purple, so 9 ways in all that you could pull one out that is either pink or purple, out of 13 in all. And so you could just write that as the fraction 9 over 13, or if you'd rather write it in decimal form, 9 divided by 13 as a decimal is about 0.692. Number 9 is an and question, because it's asking about what's the probability that the first card you pick is a diamond and the second card is a diamond. We answer and questions by multiplying. We find the probability of the first card being a diamond times the probability that the second card you pull out is a diamond if the first one was. There are 52 cards in a deck. 13 of those cards are diamonds. So for the first card you pull out, the probability that it's a diamond is 13 over 52. Now, if you did pull out a diamond on that first pick, now there are 12 left out of the 51 cards that you have left to choose from. So the probability of the second card being a diamond is 12 over 51. Then we multiply those together, not add, multiply for an and question. So 13 over 52 times 12 over 51 is, in lowest terms, 1/17, or about 0.059.